Good morning, everyone. Am I audible?
Yes, ma'am.
I think we should start with the session. Professor Rajput,
Yes, ma'am. Good morning, ma'am.
good morning. Should we start with the sessions?
Yes, ma'am. You can start.
Okay. So, good morning, everyone. For the first lecture, we have Professor N.K. Rajput from Ramanujan College, University of Delhi. First lecture is on machine learning basics. So, over to you, Professor Rajput.
Yes, ma'am. Thank you, ma'am. Gaurav sir, please allow me to share my screen.
I think we have allowed you to share.
Yes, yes. Now I can share. Yes, yes. I am. So I'm just sharing my screen. I hope this is visible. Okay, so good morning, everyone. And let's start with our first session, and which is going to be the basics of machine learning. And we will try to understand what exactly the machine learning and what are the areas and how to work in that direction. And the beauty of this machine learning and artificial intelligence nowadays is like anyone from any background, they can they can learn and they can research and they can be part of this thing. So it's like totally independent from what is your background or what is your subject. Like there's no area where this thing has not been applied, and it has not been used. Okay, so I will show few examples also in which I have worked with a few people, like a few of my friends from for FRIs, and I have also done a few work from other departments. So I will show you how you can be which NEP also suggests that we should try to inculcate multidisciplinarity and interdisciplinarity in our work. So we will try to understand this thing also. So now let's start with machine learning basics, and I will just start with one example. You must have heard about Chat GPT, and few of you, I'm sure, must have used this thing. So I will start with that only, so that you can understand. This is a very basic example. I will hardly take 5 to 10 minutes to just show you the use of it, and show you that how this AI or machine learning has played a role in it. So this is a site chat .open.ai, and you can log in with your Gmail account. So let me like this. And after creating your account, you can just see that how this it looks like. There are different versions like Chat GPT 3.5 and GPT-4, which is latest, and upgrade to Plus, so you can get more facilities if you upgrade to S. This is a perfect example of machine learning and AI, which nowadays have changed several things, and people are using it in every area. So what you can do, like for in education, let me show you a few examples in education. For example, if you want to say create questions like will this create a set of 10 multiple choice questions on say gravity, or you say, or maybe uh, uh, partial mathematics. I'm just taking simple mathematics of say grade 9, for maybe for class 9 or something. You can write like this, So you can see it will generate set of all these questions. Okay, so you see this is quite easy, and even you can write it. I will just copy this question. And in most of the cases, since it is also in the development phase, in if you write it like in Hindi. So you can see it generates the text based on machine learning algorithms. And again, the question is like where to use it and where not to use it. Is it going to harm our education system, or it is going to benefit? This is the question of debate, but definitely it is going to be there. You cannot avoid it, or you cannot say that we are not going to promote it, or we are not going to use it. What is happening now, like we have to understand the proper usage of it and how to get all the benefits from it. Okay, so you can for example, you can use it for administrative work, to write an application to generate reports, to create something new, or document anything. So for say NAC and IRF and other things, for this thing it can be used. For education, you have to blend these things, like you will have to use this thing with your knowledge and your creativity and innovation. So why I have demonstrated this, because this is a good example of machine learning, and I will show you how, what is basic behind it, and how this machine learning has been applied, or the base of this chat GPT or any AI based system is machine learning. All right, so this was a small demonstration of application of AI and ML. Now let's come back and let's understand what exactly is ML and AI. So AI, artificial intelligence, uh, it is a very big thing. So there are hundreds of things which is there, and we are now understanding which is the underlying base of artificial intelligence, that is machine learning. So apart from machine learning, there are other things also, like we call it natural language processing, computer vision, and other things are there, which is a part of artificial intelligence. But the basic building block, or the principle on which this AI system is based, is machine learning. And what exactly is machine learning? It is not like this term indicates, like learning of machine or everything. It can be applied to any kind of data set, or any kind of thing which you want to automate. Okay. So it's like learning from output. Okay, I will quote few examples. Um, switch to okay. Uh, so let's I will use this page to switch to another page. Now understand, in order to understand what are the things which we have to understand. So machine learning, with machine learning, basically it is a very broad area, but there are three kind of tasks which we machine learning. One task is like prediction. Okay, so the second task is classification, and third task what we do is clustering. So we have a data set, and we can do these things, these three things with machine learning. Prediction, classification, and clustering. I will take different examples of it. What you will see the mathematics behind it. So all these three things, they have huge mathematics and statistics behind it, and it is completely based on those principles only. So prediction task is like I will take few examples like say stock price prediction. Or maybe there is a company which produces some product, and you have the data like from 1980 to say 2000, and you want to predict what is going to be the production in 2026. Then based on the past data, you want to predict the future data, future product. So this thing is called as prediction task, and marketing people and the people from different, they just want to predict like predicting the behavior or predicting, the disease. You have the data and you want to predict like which the disease is going to be there. In fact, that is behavior of action task. But based on previous value, you are predicting something. The future value of that thing is called a prediction task, and the basic method which is there is called the regression. We learn it in detail. But I will just demonstrate how it works. Next task is classification. So classification task is very, very important in machine learning. Like you have something, you have some data, and you want to put it into two or more classes. For example, you have data of all the symptoms for COVID, and you want to make two classes whether this person has COVID or not. So here there are two classes, like one with the persons who have COVID and one with the persons who don't have COVID. So this is the classification.
S- Excuse me, sir. Sorry to interrupt you. Sir, the audio is not clear. The voice is not clear. We are not able to understand, sir.
Okay. Just interrupt me now. If it is it clear?
Yes, sir. Please repeat, sir, if it
Okay, I
is
will.
possible for you.
Okay, I will
So,
repeat it.
myself, Shifa Goel, even the full screen is not visible, sir. We are not able to see whatever you are writing.
Okay. Please stop me at any point of time if it is happening in there. Okay.
Yeah,
Yeah,
yeah.
please. Thank you. Thanks for sharing this. So I'm switching and I will repeat these things quickly. Uh, is my audio clear now?
Yes, sir. It is audible,
Yes,
sir.
sir.
It is
Now it
clear.
is audible.
And now I'm using this pen to write so that you will be able to see the whole screen because
Yeah.
there's some problem with my laptop.
Now it is fine, sir.
Okay. Thank you for letting me know about this. All right, so let's. I'm just going to repeat it very quickly. As I said, machine learning is. Okay, so, is my screen visible to all of you? Is it visible or should I?
Yes, sir. It is visible.
Okay, so machine learning. As I said, we what we do in machine learning, what is the basic thing, basic task which we do in machine learning? We perform three kind of tasks. So there are other categories also, but broadly, what is there nowadays is there are three kind of tasks which is there in machine learning. One is we call it as prediction. One is we call it as classification, and one is clustering. So these three things are there. There are some other things like supervised and supervised learning, which I will cover it later. But these are the three tasks. So I'm trying to cover it as a layman, so that you understand what exactly it is, and then we will go to the mathematical part and other parts. But I will start with a general thing about machine learning. So we have three things like prediction task, classification task, and clustering task. Prediction is like you have past values and you want to predict future values. Okay, so based on past values, you want to predict the future value. This is called prediction, and the mathematics behind it is mathematics or statistics behind it is regression. So you can see if you have a line, if these are the if this is the linear kind of fitting, you have previous values and you want to say this is in 2000, this is in 2001, and this is in 2002, and you want to predict what is going to the value in 2026. And if the data set is linear in nature, then definitely it is very easy to find out the future value. In general, it is not like a linear fitting in most of the cases. But if it is there, then you can predict the future value based on the past value. So you have all the past values and you want to predict the future value. This task is prediction and it is mostly based on regression. If it is linear, then fitting is like this. If it is non-linear, then you can apply different principles on different kind of mathematical tools for that. So this is like prediction task. As I said, the examples like if you want to know what is agriculture, say paddy or maybe wheat production of wheat in Uttarakhand from 1980 to you have the data from 1980 to say 2020 and you want to predict the value in 2025. You have the value from 1980 to 2023 and you want to predict the value in 2024. So this is a like prediction task and you can apply regression analysis into it. And this is one of the basic tasks which is there in machine learning. It was earlier also there, like in statistics, we have done these things, but I will show you how what are the new why we are putting it into machine learning thing. Why we are segregating it from the statistics. The next task is classification, which is very big task. Very is one of the most important tasks of machine learning, and it is people from every background they are working in classification problems. If you are from mathematics, statistics, biology, agriculture, forestry, any branch, botany, zoology, everyone, they have most of them they can use classification problem if they have some kind of data set with them. So or even from mathematics point of view, you can apply, you can help in developing new algorithms based on the mathematical thing. So classification problem, as I said, almost all the people are working in problem of one kind of another kind. So classification problem is like you have so what basically classification problem is? So you have some kind of data set. So I'm now taking a general example, not from the typical mathematics, like how mathematics is going to play the role in classification. I will cover it later. Let's understand the classification problem first. So you have some kind of data set, and you want to put. So these are the input. These are the input values, and this is the output value. Say I will take as I1, I2, I3, and this is the output value. And you want to, based on these input, you want to categorize these output into 2 or more classes. Okay, so maybe this is some kind of data, say for whether this person can have a heart attack or not. So based on their blood sample, maybe heart related parameters, all this data is there, and the AI-based system want to predict that whether this person might get heart attack or not. So you want to put it into classes that like healthy and risky. So you can name these 2 classes, and based on this analysis classification, what kind of algorithm, what kind of mathematical modeling you are going to apply on it, your model will put this output value into these 2 classes. This is the classification problem. And as I said, it is very important because it has applied everywhere. If you are using Amazon, Flipkart, they are using classification to categorize their customers. The game industry is based on classification problem. This airline industry, they are using classification problem. Face recognition, biometric system, biology, everywhere they are using this classification system. So they have some data and they want to put it into two categories. And now what will happen, uh, uh, based on this learning, so this is called as learning for your model. Say if you have say 1000 samples, 1000 data, and you can use like 800 to teach this model. You want to use, or we call it as training of this model. So whatever your model you're using, you are using this 800 sample values to train the model, so that it understands that if these are the parameters, then this person is healthy. If these are the parameters, this person is not risky. So 800 data values can be used to train your model, whatever the mathematical model you are going to use. And after that, what you will do with this 200 remaining data, you will test that whether your model has learned it well or not. Okay, so if your model has learned it well, then out of these 200, it will predict most of them as correct. Okay, so if your prediction values for this data is say more than 80%, then you will say that this mathematical model or this model is valid to use for this kind of problem. Otherwise, either you will change few parameters of your model, or you will switch to another model, so that you get some better results. So this thing is like that for the classification problem. So I'm repeating it very quickly. You have some input values, you have some output value. Uh, Based on these input values, say you have say 100 data set, 100 rows. So you can imagine this to a matrix. Okay, so this matrix, these row indicates the values, and this column indicates the parameters. Okay, so you have say this matrix as 100, say 100 cross, say if you have 100 cross 4 dimension matrix, 1000 cross 4 dimension matrix. And now out of these 100 values, you are using 800 values to train the model, and you are going to use 200 to test the model. So you have this training and testing thing. Uh, After this training, so any kind of mathematical, any kind of model you say, say for example, there are a mathematical model like naive Bayes. Okay, so naive Bayes model is the, or maybe I say there is another model which we call a support vector machine, which is based on hyperplane. If you're from mathematics background, so assume you will understand it very well. Like assume is based on hyperplane theory. So if you say naive-Bayes classifier, and naive-Bayes out of 1000 data, 800 has been used to train this model, and 200 for testing. And after training, your model 80% to be correct. Like it classifies correctly with 80% accuracy. And say SVM classifies it with 90%. This classifies with 80% and it is classified. So you will say that SVM works well for this kind of data set. So this is like a classification problem, and I will say it is always there. So, for example, people are using for MRI images and X-ray images. They are using this to classify your data set into two classes, whether it is for checking any kind of disease, or people from say agriculture, they can use it to like classify whether this belongs to some kind of quality assurance, like this kind of paddy is under this category, this kind of paddy is under this category. people from other backgrounds they use. I will take one more example in case of gaming industry. For example, this you must have heard about Tesla car. Tesla car is the automatic car is there. Now, what is the classification problem there? So, with all the data set is like images. There is road, there is people, there are other cars, there are trucks moving on the road, and the automatic cars. They if whatever the system is there, the model has to classify based on your previous learning that this is road, this is no the automatic car system. The picture is regularly it is taking pictures regularly, and it is classifying that into different categories. This is road, this belongs to the road class, this belongs to the truck class, this belongs to the car class, so that your the automatic driving car, it understands and it it into proper category. If the accuracy is less, in that case we cannot have less accurate values, because it has to be 100% accurate that this is the car classified it to in the road category. If suppose it misclassifies it that it is a car or a truck, it put its any truck into car category, then accident might happen. So it has to be quite accurate in their classifications in the automatic driving car. So this is this was a typical example, and this was a simple example which I took. So right from self-driving car to satellite system to this disease classification, everywhere this classification problem is there. Any doubt? I guess if you want me to repeat these things, I can repeat it. But this is very important to understand what exactly is the classification. Any question or want to comment? Please.
Sir, apart from this Tesla car example, whatever example you quoted, we had been doing it earlier, like how much people are risky for the heart disease and all. So, how is it different from the earlier perspective?
Yes, that's very important question. And I was just about to cover that thing. I just explained it while. Okay, so I will talk about. Okay, so please mute, ma'am, so that I can say it. So what exactly is different from, because you are from if you are from mathematics and statistics background, people have used it regularly. Okay, so why this machine learning is very important to understand. The first thing is like volume of data. Okay, so if you are going to use a very voluminous data, for example, credit, I will take the third example of the credit card system. So credit card companies, they have a huge data, and they want to predict that whether this type of user is going to go for any kind of fraud or not. Fraud detection, what we call it, fraud detection, based on all the previous transactions. The machine learning algorithms, they want to predict that whether these kind of transactions or these kind of users are going to get going for a fraud thing or not. So this voluminous data, you just imagine the volume of the data. Uh, Here we also call it as a big data, and our previous system, they don't work fit on it, because as the data is voluminous, and the even velocity of data is also there. So you can see the banking or credit card, they are continuously generating the data regularly, and you cannot rely on the previous so for heart attack prediction, the data is, say, it might be you have data for 1,000 people or maybe 1 lakh people, maybe 5 lakh people, that you cannot be that you can say that you can apply or your old principles or whatever you have learned, you can apply all the statistical techniques into it. But when the volume and velocity of data is continuously there, the old algorithms or old techniques, they don't fit into it, and we have to develop new techniques. So you must have heard about deep learning and other techniques. So here you can apply these principles of volume or velocity. If it is very high, then you will have to rely on new techniques, and we put it in the again machine learning algorithms. This is our first point. Another point is the data which is there, so types of data. Machine learning from a machine learning perspective, because in statistics we have heard about nominal, ordinal, data sets. So these are the things which are there only. I will not talk about that. The data of different kind, but here we deal with three kind of data. One is called as structured data, semi-structured data, and unstructured data. And one studies show that the data available in this world, most of any 80%, more than 80% of the data is falls under these two categories, and most of them are unstructured data, and very less are structured data. What exactly is the structured data? Structured data is the data which you mostly put it into tabular form. So if you have data and you put it in a table form, then you are dealing with the structured data. And algorithms, existing algorithms, they work well with structured data. You can put tabular form, you have numerical data only, and so dealing with numerical data is right, but most of the data, they are not exactly the numerical data that you have. For example, just imagine the data by Amazon, and you have the to you. The principle behind is the machine learning. It's totally mathematics. The principle behind that is totally mathematical in nature, but it is dealing with some kind of unstructured data, because it deals with images, it deals with user response, whatever you're searching, and whatever your expenditure pattern. So all these kind of data is there. You cannot put it in a tabular form always. You might be able to put few of those in tabular form, but not all of them. So this type of data you have to deal with, and in that case, again, you have to rely on algorithm based on machine learning. You cannot, it might happen that you have to deal with non-numerical data also. So you will have to rely on this machine learning algorithms. Semi-structured data, as I said, you can put it in the tabular form. Semi-structured data is like the format which is Amazon and Flipkart websites use. We call it as the few the XML and JSON, what we call it as. So this is you can put it in tabular form, which is XLS or CSV. This is the format of this. But the data which is there in some kind of HTML language format, we call it as JSON and XML. And machine learning algorithms, they deal with these kind of data also. So dealing with this, we all are familiar with this kind of data which you can put in Excel format. But the data which are available is JSON and XML. These are semi-structured data. Unstructured data is like images, audio, video, web pages. So most of the data available in this world is mostly unstructured data, and this scope of analysis of unstructured data. So you will see that all the big companies, Amazon, IBM, they are spending billions of rupees, billions of dollars into analysis of unstructured data, and people from mathematics and statistics background and computer science background, they are working in this. Okay, so it's not like only computer science people work in this, because how to put unstructured data into mathematical form, it's very important, and analyze it. Like for example, image data, it can be put, you can just imagine it to be a two-dimensional matrix with each point as a intensity value for image. Okay, so this is the mathematical definition of image. So dealing with image is just a matrix for computer. So images, this is the frequency, audio is the frequency data, video is again dynamically changing matrix. So all this we have to put it in the mathematical form and analyze it. we have to, people from mathematics and other things we will have to deal with this, because most of the data which is available there, they are unstructured in nature. Okay, so I hope the question is answered. Or you want to?
Yes, sir. Thank you, sir. So one more request. Yes, I tried to download data, but I couldn't. One more request. If you can provide data, so all of us will be working set if you are giving
Yes.
exercises.
Yes. I will give out the link of the data for you.
Okay.
Even if you people let me know the background or your subject, then I will try to find out your subject related data only,
Okay.
so that you can relate to it.
Sir, I am from mathematics.
Okay.
Thank you, sir.
Okay. All right. So this is like as I said, the data is most of the data which are semi-structured and structured data. Now, the problem is like how to put it into mathematical form, how to analyze it mathematically using mathematical models. So this where the mathematics and statisticians they have to, because computer science people they can write codes and they can develop algorithms, but mathematics behind it, either computer science people will have to learn that, or maybe mathematics people, if they learn computer science, basic computer science, and people can work, and this is completely interdisciplinary work, as I said, like the case of Tesla car also, it is like completely interdisciplinary, because this is a pure classification problem. Okay. So now let's the third classification. So I was talking about classification problem. Classification problem, and third category was clustering. There is a basic difference between uh, is healthy risky state based on the previous data. So input one, input two, three is there, and the outcome is there, and we have two classes, healthy or risky. Okay, so we know about all these data, and we call this data as labeled data. Okay, so we know that these are the parameters, and this person is risk of this class risky. These are the parameters, and this person is healthy. So we know about these data, and we know these labels of the output values that we already know about it. So if you know the output values, then we call it as a labeled data, and if you don't know about it, then we call it as unlabeled data. So we know that this person is at the risky stage, this person is is healthy, so we put in these two classes, so we call this data as labeled data. But what if we don't know this thing? Okay, we don't have this column only. Okay, so this column is not there. Okay, we have only these kind of data, and now to put it, you want to apply it some kind of this one. We don't have labels. Okay, so in that case, we apply what we call as clustering. So based on the data, it automatically tries to find out the similarities or dissimilarities, and based on it, it can make different clusters. Maybe two cluster, maybe three cluster, any kind of cluster is there, and we can analyze these clusters. That yes, this cluster seems to be like healthy one. This cluster seems to be like unhealthy one. These clusters is like we are not able to identify it. It's like something in between these two things. So if you know, the data is labeled, or we know about the data, then we call it as a classification problem. If we don't know about the data, or we don't know the labels, then we call it as classification problem. We put it as so you can define it to any kind of, and again clustering they have importance. Uh, they they use different techniques where they use distance between these values and other things. We put again the clusters to inter distance or intra distance. So in this is distance and interdistance. Based on these techniques, we use the question. So this is going to be, this question finally. So these are the data, and based on this, we have these three kind of ones. So if we want to predict anything from the previous values, past values, we call it as prediction, and the principle which applies on it is regression. Mostly they use regression for it. If we want to put it into two or more classes, then it's called as classification problem. And in classification problem, we have levels of data that we know that these are the outputs. If we don't know about it, we don't have the labels for it, then we call it as a clustering problem where we don't have labels. And the classification along with classification and regression, they are called as, the learning behavior is called as supervised. And clustering is under the category of unsupervised learning. So I'm, taking several names. So let's understand this. And if you want me to repeat anything, please let me know. I will, try to give another example to make it clear to you. But just make sure that you understand these things. Okay. So supervised learning is like the things, past things, and you want to predict the next values. Okay, for example, here we know the data set about 1,000 people. Okay, so we have trained the model to predict the values, or we have trained the model to predict the values which will come in the future. So we have trained a model of these 1,000 values. Now say new patient comes and we have the input parameters for that patient and we want to predict whether to put in any class. So we can use this as a classification problem. As I said for the Tesla car also, we have trained self-driving car that this is road, this is just based on the image data. So you can see the data for Tesla car or self-driving car. It is not a numerical data. Indirectly, it can be numerical because image is a matrix. Again, as I said, it is a matrix, two-dimensional or three-dimensional matrix. But but it cannot be put in the tabular form. So we call it as, we can say that it is unstructured data. So for a self-driving car, the data is the model has been trained to identify whether this is a road, whether that image belongs to the road, or it is a car, it is a person. It has put in. Suppose we have trained the model, and now the car has learned. Now, if the car is moving in the road, it has to classify based on the image data that whether it is and it has to do it very accurately, boost 100% with accuracy. Otherwise, it will not know. So this is like a classification problem, and this is called as a supervised learning. Because we have already trained the model based on our supervision, based on the supervision of the data set, okay? Based on the labels, the data. Based on, for example, in regression, we have the past values, and we are, defining the model or tuning the parameters so that it can predict the future values. So this is called as supervised learning. In case of if this the output is not given, only the input parameters is there, or so we don't know exactly about this data, so we cannot supervise the model to train it. So this is called as unsupervised learning because we don't know, we don't have the output, and we cannot train the model to predict anything or to put it into classes. So we cannot apply the classification problem in the classification problem. We cannot train the future value. We cannot train the model to classify into two categories. It has to be done based on some principles, mathematical thing, distance, Manhattan Euclidean distance, or any kind of mathematical thing to clusters. For example, another example, we have the AQI data here for the index data for several cities. Say we have data for 100 cities in India, and we don't know that whether to put it in good terms, whether we can say cities safe or polluted or not. Say we don't about it. We have need the data. So now we can apply the cluster because we have not classified whether how much AQI is to be there for polluted city. So we can apply the clustering. It will automatically generate different clusters. So that you can this cluster belongs to, we can say about this cluster is polluted, we can say about this cluster is to not polluted, very less polluted. So if there are 3 clusters and we can name it like this, if there are 4 clusters, we will have to put some other names to it. And any question related to this? Any doubt? Okay, so my voice is clear. This voice is not clear. I'm audible to you.
So be little bit loud. It is not very clear.
Sir, also one request. Sir, actually, we are not from artificial intelligence background. So you are requested to kindly make some easy examples that we can approach easily. So that those examples could be easily understood by us. It is not possible for us to grasp all the things that you are
Yes.
giving.
That's why I'm saying that please stop me or ask me to repeat anything, or I will try to give some other example because I am taking a general life examples like for example self-driving car or these things I'm taking the name. If you want me to take another example, let me know. I will try to be as simple as possible because we before moving to understand all the concepts of machine learning or artificial intelligence, we have to understand these terms very clearly. So just
And sir, one more request, sir. Be slow. You are very fast, and it is not possible for us to grasp each and every aspect that you are.
Okay, I got the point. So it's just I request all the participants just let me know what exactly you want me to repeat or what the problem. For example, if I say, have you understood about this data, these 3 classification, these 3 categories, or you want me to repeat it? Just let me know about this.
Please,
You understand?
please repeat, sir. Please repeat with simple examples that we
Yes.
can understand.
Okay, structured, semi-structured, and unstructured. Okay, structured data. So as I said, so we have structured data like this. Suppose this is the wheat production in India. So we have the wheat production in India, and we are predicting like here we can say that in 1980, 1981, 82 up to 2023. Okay, and this is the yield. Years and yield. So this much of metric ton or this much of 28 metric ton, and this is the data. So this kind of data where you can put it in the tabular form, this is a structured data. Okay. So if you are able to put it in the tabular form, and because analysis of tabular data is easy, you can analyze it in Excel, you can use SPSS, you can use MATLAB for it, you can use R, Python. There are several tools which you can use to understand this or analyze the structured data. You can from the basic statistics like regression, correlation, and other things, you can do it several things with this data. Okay, so this is a structured data. Is this clear? What exactly is the structured data? Any kind of data which can be put in tabular form or which are simple to represent it. Okay, so that is structured data. Is this clear? Any all of you?
Yes, sir. Clear. Thank you,
Yeah.
sir.
Okay, now let's understand semi-structured data. So let me show you an example for it. Yes, I'm just googling it so that you can understand this. So see this kind of data. Okay, so this is again a data. This data is like two prompts. So Jani is sending something to Tor. Reminder, don't forget me this weekend. Okay, again this is a data. Okay, it's very difficult to understand because we have not dealt it with this kind of data, but this is again a kind of data, okay, which is there. There is no numbers and there is no numerical or any other kind of data is there. But this is again a data, and we have to deal these kind of data, and we have to use our mathematics for this also. Okay, and this data is called as semi-structured data, and you cannot apply Excel, or the knowledge of basic statistics like mean, median, mode, or correlation or regression to deal with this kind of data. You will have to search for new kind of mathematics or new kind of tools or to deal with this kind of data. And this kind of data has been generated regularly with big people, like for example Amazon, Flipkart, and all these shopping websites and banking industry, credit card industry. They generate this kind of data. So we have to be very clear how to deal this kind of data, and for this machine learning tools is useful, and there are techniques which can be applied to deal with this kind of data. Is this clear? This semi-structured data?
Yes, sir. Clear, sir. Thank you.
Yes, and now let's understand the unstructured data. So you see, you have say images. You have images like, for example, MRI images there. Okay, if you search for it, even you can get it by each data set. Brain image. So you can see this data set is there for brain tumor detection. And so I'm just so this kind of data. So you can see these are the images. So definitely you cannot put in the tabular form, but this is again a data set. Okay, it is not semi-structured because it is not in that format which we have seen this. This is not in this format. This is the image data, and even you cannot put in tabular form, but definitely you can represent it mathematically, because as I said, this image can be called as it can be represented in matrix form. It can be considered a two-dimensional matrix, and you can say that this black color is say one value, and all the white color. If it is a black and white image, it's very easy to represent it, because it is black and white image. You can say that black is 1 and white is 0, and 1 0 1 0 1 0, and it is a two-dimensional matrix for each point. So this image can be represented mathematically using matrix, but the data is not cannot be put into tabular form. So we can consider this data to be unstructured data. Okay, and dealing with these images, and so it is not exactly unstructured data, because we can analyze it definitely, but it is not. It cannot. We cannot put it in the tabular form. So dealing with this kind of data is different, and you have to rely on different algorithms for this. You cannot apply your basic statistical tool to analyze this kind of data. So this is again a third kind of data which I was talking about. So now is this clear? Unstructured data.
Clear, sir.
Yes. So images, audio files, videos data, video data. For example, Mars rover is there or Chandrayaan is there. It will send video data or say some kind of images, and analyzing it using machine learning. You can use MATLAB for that also. So this kind of analysis is different from whatever we have learned till now. So machine learning has to deal with every kind of. So machine learning is a broad thing which covers like dealing with all kind of data, which is different, which we have done previously, like dealing with numerical data. So numeric data and non-numeric data, we have to deal with these two kinds of data, and how to represent any non-numeric data into numeric data, it is again a challenging task. As I said, audio file can be represented with a set of frequencies, and frequencies again can be written by numbers. So first we have to understand these data and to put it into mathematical form. So this was about data. Any one of you have still any questions about it? Please let me know. I will give a few other examples also. Otherwise, I will wait. So let me again explain the other things also. So classification, that's it. Classification is a kind of supervised learning. So all of you, do you want me to explain these two terms again, or have you got this thing? So if you have not understood it, then I will try to quote some different example.
Please, sir.
Okay. Okay, so label data. Okay, and now I will quote some example. For example, you have images of say 1000 images of say dog, cat, and you have say out of 1000 images there are say 580 220 images of dog, 5 of dog and cat. Okay, so this is again a data set, and this is this is not a structured data. And now we classify like so that it classifies it identifies accurately like which is which image which is so what we will do out of these 1000 images we will put it into, and this is again labeled data. Why we are calling it labeled data? Because we know about what images. We know that out of 1580 is of dog image, 430 is of cat image. So this, since we know about the data, that is why we are this labeling. अगर हमें नहीं पता होता about this, अगर इसको कहते हैं कि this is unlabeled data.
Sir, audio is not clear, sir. Audio is again not clear.
Okay. What is second? Let me check the setting of audio. Okay, I'm stopping sharing so that I can check my microphone again, and then I will share it. Is that okay? Just give me a minute so that I can check my audio settings. Hello, hello. Am I audible now, or is it just the same?
Yes, sir, audible.
Okay. Okay, so I guess in the next session I will change my microphone. All right. So yes. So you got this point, like what is labeled data? We know that these 1000 images are there, and out of these 580 is of dog's image and 420 of cat image, and we know about this. Okay, so since we know about this, that this is an image of dog, 580 images are of dog, and we know that 420 are of cat. That's why this 1000 data set, the 1000 images, we call it as the label data. And if we don't have this information, we have only this images, collection of images, and we don't know which one of them are dog, which one of them are cat, then it will be called as unlabeled data. Is this clear? Labeled data, unlabeled data.
Yes, sir. Clear, sir.
Yeah. And so you can just find out if you download any data or you collect any data, you can put it into these two categories. Like this is labeled data or this is unlabeled data. If it is labeled data, then whatever the technique we will apply on it will be in the supervised learning technique. We will call it a supervised learning because we already know about this data. Now the question arises, if we know about the data, then what is the use of it? Okay, so what is the use of it? What is the classification problem behind it? Like we know about these 1000 data set. We have trained a model. We are trying to build a model which understands that these are the images of dog, these are the images of cat. Now some new image arrives, some new image comes, some new image is to be tested. Then if this model was good, then it will be able to predict exactly that this is the dog image, this is the cat image. Okay. So this is basically the goal of classification problems, that you train a model, you test a model. Now this model is can be used for the real time problems. Okay, so if the model has been trained and tested very accurately, then the model can be used for the real time problems, for solving the real time problems, for solving the real time classification problems. So this is a kind of supervised learning because we are training the model based on labeled data. We are training the model that see this image is of dog, see this image is of cat. We are training the model to understand the difference between these two terms. So that's why it is called as supervised learning. We are building a model under our supervision, under the data which we already know about. Okay, so that's why it is called as supervised learning. So these terms are clear, like classification problem. Classification is like putting the data set into two or more classes. Yeah, so out of these two images here, we have two classes, dog and cat. Okay, and the data is called label because we know about this data already. That these are the dogs and these are the cats, and we are training our model to predict it correctly. And this is called a supervised learning because we know about these things, and we are saying that model that see this is dog, this is cat, and something like this. So is this still clear? These three terms, classification and supervised. Yes.
Clear, clear, sir. Clear.
Yes, yes. Yeah, other participants also, I request if you are not able to understand it, so please feel free to ask, because if you don't ask and if you are, then the future you will not be able to apply it on your data set, or you will not be able to understand mathematics behind it also. So just make sure that you understand these terms very clearly. If you still have doubt, please feel free to ask. All right. So the classification problem I said about, like for 1000 data, we just put it into we make it into two categories, or we divide it into two categories. One for training, one for testing. And I will show you we can do it in MATLAB very easily. Just you upload data and select how much to use for training, how much to use for testing, and we can go ahead at this. So 1000, say if there are different ways, like we can say that 80-20 ratio, or we can say the 70-30 ratio. That means 80% of data we will use it for training and 20% for testing. Or in this case, we can say that 70% of data we will use for training and 30% for testing. Okay. So training and testing, we divide this data set into two parts: training and testing. And for training, say we suppose we have used this model, for say regression or maybe classification. Let me take a very simple example. We are training with this model. Okay, so what will we do, or maybe I will put some other question. Say y is equal to c x squared plus p x plus e. Something. Say this is the model.
Excuse me, sir. Sir,
Yes.
what comes under training and testing? What is the difference between these two, and what we are doing in training and what we are doing in testing?
Yes, yes. That is what I am explaining now. So training means that say here say I am training this model, and this is the mathematical model, and I am going to train this model. So what we mean by training here? I am providing this data set. This is the out of this relatively or which is selected like this. So I will provide this model 800 values. 800 values to this model. This is our model. And I'm going to provide 800 model to this thing. Okay, it's a this equation, mathematical equation. And what is meant by training that we have to identify what is going to be the value of CDM. Okay, so say first data arrives, it predicts some value of C, D, and E. Okay, because we have y and x. Okay, y is the output value and x is the input value. We have this data with us. Okay, and now we have to find out the value of C, D, and E. So for these values, we for say first values come and it predicts the value of C, D, and E. So the next value comes, it modifies the value C, D, and E because it's now we have two data sets. The first value is come, we will find out the value of C, D, or the value of C, then the value of C. The second value is come, it will modify C, D, and E so that it fits to these two data. Now the third value is come again, say this is the value, it will modify again this value C, D, and E to fit into this data. And again, for all the 800 data, it will keep modifying this CDN. Okay, because we know y and x, we have input and output values. We do the label data, and we know that for this x or this y, and we are still trying to find out CDN. So this is called as training. Is this clear? Training means finding out values of parameter for the mathematical model which we have used with our data set. Okay. Now let me clarify the testing. Then you can ask me the questions. Now, what is testing here? Testing here means now we have find out whether C, B, and E. Now it's time to test it whether it has predicted its correctly or not. So what we will do here, the testing phase from with the other 200 data. We will not provide the value of y to this model. Okay, we will hide the value of y from it. We will provide the value of x, and we will provide the value of C, D, and E, which we have obtained from training data. Okay, we have trained the model. We have training with 800 data sets. We have identified the value of C, D, and E. Now with this 200 data, we will hide this value of y. We already know what exactly the value of y for these 200 values, but we will not provide these values of y to this model. We will give the value C, D, and E, which we have obtained by training with this data, and we will give the values of x in this model. And now we will see that what it it generates the value of y based on its training. Okay, so now the out of this only the first value, it predicts it very accurately. Okay, so we will measure the difference between them. So for example, some prediction value or maybe the real value is say 135. When it is testing data, it has generated say 134. So we will say that the error is very less. Okay, and we will keep it as accurate method. The next value will arise. The 200 value after these two value, the next value comes, and it again we have not given the value of y to this model. We ask that predict the value of y. And it predicts say 100. The real value was say 145. And it predicts 145. Then we will say that 100% correct. And we will add that the model is correct. Okay. Next value is say the real value which we have already with us is say 143, but it predicts say 120. So this is a huge error, but we will say that it will come under that wrong kind of wrong prediction. And we
Excuse
will,
me, sir. Audio is not clear, sir. Please do something, sir. Your lecture is very nice, but we are not able to uh, hear it properly.
okay, okay. Well, let me change the mic. So I will stop. Then I'm just trying to find out new headphone. Then I will continue it again. Okay.
Okay, sir.
Just a 3 minutes break. Okay, so that I can change my microphone. The headphone है क्या दूसरा? इसकी आवाज नहीं जा रही इनको. Okay, so my my audio clear now?
Now it is appearing that it is clear, but sir, it will be decided when you will give the lecture. Since as before you asked us, we said that it is clear, but in between the lecture, we do not know how it happened.
Okay, so I have changed my headphones, so I guess should be like this only. So I'm resuming this. So should I repeat this part again?
Yes, sir. Yes, sir. Yes, sir. We will be thankful to you, sir. Please repeat.
Okay. Let me just repeat this whole part again. So as I said, say you have 1000 data set where we have a tabular data. I'm not taking the image kind of data. Say this is the numeric data, and you have say input different kind of inputs and one output. Okay, and we have all the rows here with all the data set. Now we have this 1000 data. We are classifying. We are putting it into we are dividing this into two parts. With one part we call it as a training data set, another part we call it as a testing data set. Okay, so if out of the 1000, say this 800, we will use it for building, or these 200, we will use it for testing. Okay, so 800 for building and 200 for testing. Okay, so this clear, like you're dividing this data set into two parts, training, one part for training, 800 part, 800 data set values for training, and 400 data set values for testing. Okay. Now, what exactly is this? So, say this is the numeric data, and so that we can apply any mathematical model. For example, say where here we say output and beginning of flow, we say that we will say A of I1. The it is a unique kind of solution, or maybe the
Sir, again, same problem, sir. No audibility of your sound, sir. It is very echo problem.
eco problem.
Yes, sir.
Okay, so what
And sir, please speak loudly, sir. When you are interacting with us, just like if you are interacting, you are saying something personally to me. It is very clear. But when you are delivering the lecture, it is not clear. That's what I want to say.
All right, so maybe should I stop it here because I will have to change the place. मैं जगह change करके वो करता हूँ और should I continue it at 2:30?
No problem, sir. Yes, of course, sir. Since that lecture will be much great than the lectures in which we would not be able to understand.
Okay, so
No,
what you suggest?
sir, you can
Gaurav's,
change you can change the place. You can change your setup, and when you will feel comfortable with the mic, audio, and video, we shall rejoin with you.
Okay, okay. ठीक है तो गौरव जी, नीता मैम, what do you suggest? या अभी
So
मैं stop.
while you interact, it is very clear. But when you are explaining us, then it is not clear.
Okay. Okay, so क्या मैं voice
That's
Maybe
what I have said. That when he is talking to us, it is not clear. But
no,
when
when he
he
is
explains,
talking to us, it is very clear. But when he explains, then it is not clear.
yes, of course.
Yeah.
Okay, okay. ठीक है तो maybe should I continue after this ब्रेक, और या इसको मैं प्लेस चेंज करके भी, तो प्लेस चेंज करने पे मुझे लग रहा है कि 15-20 मिनट लग हो जाएंगे, तो क्या सजेस्ट करेंगी मैम आप?
Anything which you decide and the participant decide.
ठीक है तो अब बाकी लोग में कोई सजेशन, मैं या फिर वही आगे जो भी सेशन में उसमें कंटिन्यू करूं 2:30 बजे है, आई गेस उस पे
No
कंटिन्यू
problem,
करें,
sir.
क्योंकि
No problem,
ठीक है।
sir. We are willing to attend your lecture. It is very interesting lecture. Much concepts have been cleared by you. We want your lecture.
ओके, ठीक है तो मैं अभी प्लेस चेंज करता हूँ,
Is
बाकी
there any
मैं
network issue at the place where
यस मैं कॉलेज में हूँ, तो मे बी अभी मैं वो इधर शिफ्ट करता हूँ, मैं अपना घर पे ही अभी पहुँच के फिर ज्वाइन कर सकता हूँ वहाँ पे बेटर थोड़ा होगा मेरे पास रूम है, तो सो अभी या फिर स्टॉप करता हूँ मैं, क्योंकि अभी मैं जगह भी यहाँ पे भी चेंज करूंगा तो इट विल टेक सम टाइम। सो वहाँ पर करते हैं 2:30 बजे इसको कंटिन्यू करूंगा मैं। Meanwhile, बीच में शायद अभी और lectures हैं, and I guess there is one lecture for MATLAB, and that will से भी मुझे थोड़ा हेल्प मिलेगी, क्योंकि it is again going to be some plot and other things जो last resource person ने पिछले भी लिया था, तो it will be beneficial for you, and MATLAB पे So after completing this session, I will switch to MATLAB and I will show you how to do it practically with the data set. Okay, I will also show you how to download the data set from this different platforms and how to use it in the MATLAB to just go for classification and regression problems. थोड़ा बेसिक्स आज करेंगे एंड बाकी टुमारो तो रिग्रेशन पे डिस्कशन है काफी, तो ये वाला करते हैं अभी। मैं 2:30 बजे फिर ज्वाइन करता हूँ, अभी के लिए थोड़ा टाइम आप लोग बाकी जो दूसरे लेक्चर्स हैं एंड कैन हैव योर लंच ब्रेक। इज दैट फाइन विद एवरीवन?
Yes, sir. Fine, sir.
ठीक है, then I will continue at 2:30. Till then, let's have a break and we can have the other session with that.
So next lecture is at 12. So till then, you can enjoy the break.